Section 3.11, Related Rates. This section, we are going to solve the word problems involving the derivative or the rate of change with respect to time. The procedures to solve this part of the problem, starting with read the problem carefully, making a sketch or draw the diagram to organize the given information, identify the rates that are given, and the rate that is to be determined. Step 2. Write one or more equations that express the basic relationships among the variables. Step 3. Introduce rate of change by differentiating the appropriate equations from step number 2 with respect to time t. Step 4. Substitute known values and solve for the desired quantity. Step 5. Check that the units are consistent and the answer is reasonable. Example 1. Assume that all variables are implicit functions, and we have the implicit equation as x squared plus 5y squared plus 6y equals 10. Both x and y are function of t. Find dy by dt. If dx dt equals 12 when x equals 2 and y equals negative 3. So this is a set of the given information. And this is the dy by dt is the unknown. So what we are going to find. Now, from the equation that provided, which is the implicit equation, is the equation to tell the relationship of all variables, which are the x and y. Next step, we're going to find the derivative with respect to t to all terms. You get d by dt of x squared plus d by dt of 5y squared plus d by dt of 6y equals d by dt of 10. Again, x and y are the function of the t, so we can treat them as the chain, using the chain rule. The first term, we're going to get 2x dx dt. Second term, we get 10y dy by dt plus the third term, which is 6 dy by dt equals the right-hand side, which is 0, or the derivative of the constant is 0. The problem asks you to find dy by dt. We have two terms that contain dy by dt. So we're going to keep this two term on the left and move to x dx dt to the right and collect the coefficient to get 10y plus 6 multiplied by dy by dt equals negative 2x times dx dt. Therefore, the dy by dt equals negative 2x multiplied by dx dt, all divided by 10y plus 6, and evaluate the values where x equals 2, y equals negative 3, and dx dt given to be 12. To get the number negative 2 multiplied by 2, dx dt, which is 12, all divided by 10 times y, which is negative 3 plus 6. So we get the answer as positive 2 as the rate of change of the y with respect to time t. Example 2. The size of a square increases in length at a rate of 6 meters per second. At what rate is the area of the square changing when the sides are 17 meters long? So first of all, we're going to draw the diagram. This is about the square. Draw the square and identify the given information. We have the rate of change of the size at 6 meters per second. And the question asks for the rate of change of the area. So make a list here. The variable involving would be the size, which is x, and the area a. The given information, we have the rate of change of the length, which is dx dt equals 6 meters per second. Since this is increasing, the sign is going to be positive. And the question asks for the rate of the area, going to be asking for dA dt when the size, which is x, equals 17. Okay, from the list here, we're gonna set up the equation that shows the relationship of both variables x and a. For the equation, the area of, the area of the square, which is a, equals x squared. And next, we're gonna find the derivative with respect to time, or do the implicit differentiation. We get dA dt equals d by dt of x squared, or we get 2x multiplied by dx dt, which is the form of the dA dt. The problem asks you to find the rate of the area, which is dA dt, and then use the known information, which are the x is 17, so 2 times 17 multiplied by dx dt, which is the value 6. Therefore, the answer is 2 times 17 times 6, which turns to be 204. And the unit, since this is the rate of change of the area with respect to time, the unit is the unit of the area, which is the square meters per unit of the time, which is second. So the answer is dA dt equals 204 square meters per second. And the positive side, that means the area is increasing. Example 3. When a circular plate of a metal is heated in an oven, its radius increases at a rate of 0.04 centimeters per minute. At what rate is the plate's area increasing when the radius is 40 centimeters? The diagram that we are using in this problem is about the circle. So circle. And the given information, the radius increases at a rate of 0.04 centimeters per second. So let's make a list of the variables. It's involving the radius. We use the r as a radius. And the rate of change of the radius is provided. So dr dt increasing positive side at a rate 0.04 centimeters per minute. At what rate is the plate's area? So that's the unknown. It's about the area. Let A be an area of the circle. So the unknown would be dA dt, or the rate of change of the area. And the hint, the area is increasing, so the sign of the dA dt going to be positive. We're going to find dA dt when the radius equals 40 centimeters. From the circle with the radius r, the equation that show the relationship of these two variables would be the area of the circle, or A equals pi r squared. We get the equation. Next step, we're going to find the derivative with respect to time, both sides of equation. We call the pi is a constant. So we treat pi as a constant multiple to the r squared. The dA dt equals pi times dr squared dt. And the derivative of the r squared with respect to t would be 2r dr dt equals dA dt. The question asks for the dA dt. Now we write it as 2 times pi times r when the r is 40, and multiply by dr dt, which is increasing rate of the radius as 0.04. Then simplify the numbers to get the answer as negative not negative, sorry. It's gonna be positive 3.2 pi